Okay, now we're going to look at the second form of representing algorithms, which is pseudocode. So flowcharts was the first method, and that itself is a pictorial or graphical method of representing algorithms, where pseudocode itself is a semi-structured form of English. So it's written, makes it very easy to implement into programming languages, and it's the preferred method for trying to generate complex solutions to problems. So in looking at it, it's semi-structured. Basically, the control structures of sequence, selection, and repetition, they are what is the structures. They're non-negotiable. You can't change them. The rest of the aspects of the algorithm is open to interpretation by the designer of the algorithm, and it's up for the programmer themselves to actually interpret them when they're putting them into a programming language. There are some rules, so any control structure, so if you're looking at binary selection, the if, then, etc. must be in capitals. Every time you use a structure, they must be indented to show that there is a structure that exists within the algorithm and logic, and any subprograms that are used, their names must be underlined. So we're going to have a look at the first type of selection structure. It's the same with flowcharts. We're going to look at binary selection, so there's one of two methods, and the syntax or the structure for this is if a condition is met. So that condition is up to the designer, but if that condition is met, then a process A will be executed, else process B will be executed, and the algorithm itself is ended. So the if, then, else, and end if, they are all non-negotiable. They must be included. Whatever you have as your processes or your conditions is up to the designer of the algorithms to decide. So we're going to look at a very simplistic problem, which is a number guessing game is required. And we're just going to go into a text editor, and basically, as with flowcharts, begin and end are the non-negotiables. They're in capitals. And the first thing, so we're just going to tab in, and our first process that we want this algorithm to do is in a variable called random number. We want it to store, and the computer is going to generate this input. We want it to generate a random number between 1 and 10. Now obviously you couldn't just enter that, generate a random number between 1 and 10 into a programming language. The programmer themselves would have to generate some randomized function, but it's giving the programmer the steps into solving that problem. The second thing that we want to do is we want to get a user input, and we want to get user number. So we want to get whatever is their guess. Now this is where our binary selection will come in, so our control structure. So we basically want to say if random number equals the user's number, then we want something to happen. So if that is true, so if both numbers are the same, we want to print correct guess. Now bear in mind, for printing correct guess, I've put that in inverted commas, and that identifies it as text. If I didn't have the inverted commas, a computer would treat that as an actual variable or a constant, so it would assign a value to it. Now if those numbers do not meet, we've got to have another path for it to take, and that's where the else comes in. So if the two of them don't meet, we want it to print incorrect guess. And the last thing that we have is our end if. So there we can see here that we've got a binary selection, so one of two paths, so that's binary number system 0 and 1. So if these two variables, if they equal the same, then the computer will output print guess, correct guess, sorry. If they don't meet, the computer itself will make the decision to print incorrect guess. So we've got inputs. Random number is one input, which is generated by the computer, and we have user number, which is an input that is generated by the user. Both of those are variables because they will change through the execution of the program, how many times this is repeated. And then we've got a condition. So a condition is, does the random number equal the user number? If that condition is true, we take this path. If it's not true, we take that path. And both paths lead to some form of output. So that's an example of the syntax behind a binary selection control structure. And as stated there before, our indentation shows perfectly the if, the then, the else, and the end if. And all of those must be correct. If I did not include the end if, then therefore that would not be an appropriate binary selection control structure. It must follow that format. Doesn't matter what I put in as print correct guess. I could put print great guess and print poor guess. It doesn't matter what that is. But the if, the then, the else, and the end if must be there for it to be